This is part of a series of videos on number structure. I felt that it would be important to understand how number structure is used in everyday applications, and this might help you overcome some of your math phobia when you recognize how important number structure is to your financial soundness. So let's begin. We're going to talk about the following four subjects. What is number structure? Then we will talk about merchandising tricks and what keeps you from doing comparison shopping in the areas of pricing, itemizing repairs, and discounts. And then we get into rates. That's ratios and fractions, credit cards, mortgages, student loans, savings. And then finally talk about how our measurement system doesn't really take full advantage of number structure. So, what is number structure? It's relatively simple. It's a method of grouping numbers and then grouping the groups. The purpose is to make very large and very small numbers understandable within the psychological and physiological limits of the brain. 39 random objects arranged in tens and units. So we have three groups of 10 and one group of 9. We recognize those tens as being 30 and then the 9. So our focus will basically be focused on that first number. A second example we have is if we have a number shown there with lots of 9s and 4s and 3s, when we separate them by commas, the number is more understandable. Okay? So that number is approximately 999 billion. And then we also have a technique using exponents, where now we've taken this very large number and reduced it to something very small, something that our mind can grasp onto. And then we have another area where we have primes, where we're breaking our numbers up into small parts. So for example, 12 can be written as 2 times 2, which is 2 squared, times 3, a much smaller set of numbers. And that will become useful in improper fractions or in reducing fractions. And then another part which we don't see in school at all is number structure in terms of our exponents. So if I raise 10 to a decimal power, I can break that up into two parts, 10 to the quarter power and 10 to the 1/8 power. And I can see that these numbers will get closer and closer to 1 as I get smaller and smaller values. So this is a way of taking numbers and making them comprehensible. Manufacturers or retailers take advantage of our math phobia in terms of the way they present things. So let's take a look. You've seen on television where you can buy something for $19.95 plus shipping and handling, which comes around $5.95. When our mind looks at that, we see this item as, oh, it's just a little bit more than $10. Some of us are a little more knowledgeable, we'll round it off and say, oh, that's $20. Now, it's a trick that the gas stations pull at us when something is $2.99 and 0.9 cents. Why couldn't they just make it $3? It's the same psychology. But then we add another $6 for shipping and handling, and that item now comes, that $10 item in our mind now becomes almost $26. It's because our mind runs down and ignores the shipping and handling to make the price look reasonable. Okay, and another trick also is to do it in monthly installments, where we can charge something like $80 and break it up into 4-month installments at $19.95 a piece. And our mind tends to forget about the other 3 installments. If taxes were charged on top of this, the item would end up being $28.40, which is about a 30% increase over the price that we perceived. Another trick that is done is, I find this often with auto repairs, restaurant bills, and hospital bills. You go in for an auto repair bill, and they itemize everything, and all these little numbers begin adding up to a big number. My technique is I go in and say, tell me what the final cost is with taxes, so that I will know what I'm paying. And in some cases, this helped me shop around and get something at a much reduced price. Restaurant bills, not much you can do about it if you want to splurge a little bit. But as soon as you start adding drinks and desserts, your $20 meal can end up being $40 meal. And hospital bills, well, we've seen how hospital bills have ballooned, and we see that you can end up a dozen charges for some simple visit to the hospital. And it gets hard to argue each of these bills because they are a collection of bills that come from individuals. I remember when I was in the hospital, a psychologist came by, said, "How are you?" and walked out of the room because I said, "Fine." That visit cost me $100. A whole lot of small numbers totaling to a charge well beyond what we'd like to pay or expect is the problem that we run into with this itemizing of repairs. It makes it difficult to shop around too. The other thing I brought into this is discounts. It turns out that stores will offer you a 30% discount and then a 70% discount. For the naive, they think they're getting a 100% discount, where it's basically you're paying 20% of the price, and so if an item is $100, you end up paying $21, not no dollars. Students have been shown the hard way to calculate these multiple discounts. I'm not going to go into details here, but there is an easy way, and I found that this was very useful when a relative of mine was looking at multiple discounts and wanted to find out what the price was. Okay, now we get into another area where you will be amazed at some of the extra costs that you pay for a lack of knowing how numbers are structured and how to play with them. Okay, credit cards, what I found interesting is 13% used to be considered a rate that was usurious. Now you see 25% charges. A late fee on a bill, let's say of $40, can end up costing you $40, which if you annualize that, comes out to be a 1,200% interest rate, well above 13%. Because of these high rates and these extra charges, it's a little bit somewhat easy to negotiate, at least I've been told, on delinquent bills, because the credit card companies are making a lot on these little fees that begin to add up to big fees. Mortgages, these are a necessity of life. If you want to buy a home, to save up for the home could take decades, and if you'd like to make advantage of that at home, you're going to have to take out a mortgage. What you want to do is negotiate for as short a period of time as possible, because the interest rates add up very heavily. You can pay 2 or 3 times even more of a home if you take it out for 30 years at some of the higher interest rates. The other thing to watch for again is, as you saw with auto repairs and so on, when you're buying a house, there's a lot of closing costs, and you could be in for a surprise. Reverse mortgages, be aware of how your house is evaluated and the conditions. I haven't looked into details, but somebody was telling me that you don't get 100% value of your house, and there are lots of other surprises, like you still have to pay insurance and maintenance of the house that no longer belongs to you. Okay, student loans, another one. My son got a student loan. There was no interest had to be paid until he graduated, and then the interest jumped to 15%. Okay, basically I said, look, I'll lend you the money. Being a parent, I didn't charge him any interest rate, but if you choose to, it turns out it's better for both you and your child rather than to take that loan and pay an exorbitant rate on it. Okay, savings accounts, again, you want to look for interest rates. One of the things I found interesting is that Christmas accounts, which were a forced savings account, you had to pay to save your own money. That's the cost of not being disciplined. So as you can see, there are lots of little interesting things happen with money that basically, if you understand number structure, understand interest rates and things like that, you can save yourselves lots of money over hidden costs that come in. Okay, so now we want to look at measurements, and this was something that really surprised me, particularly within our own English system of measurements. So I'm just going to take a few examples of that. If you were going to New York City and I told you it was 5 million inches, you'd have no way of comprehending what that distance is. That turns out to be 90 miles. And the reason why I bring that up is one time I asked somebody if they took 3,661 pictures and it took 3 seconds for each picture, how long would it take them? And they gave me an answer of 10,000 and some extra seconds. I said, 10,000 seconds? Okay, then the person reluctantly converted that to hours and minutes. So these are good examples in terms of how number structure takes place in our measurement thing. However, the other interesting thing is if we look at our measurements, a 1-foot shelf is actually 11 inches wide. I once measured it and went back to the store to complain. They said, nope, it's 11 inches. And when I bought the brackets to hold it, they took care of this 1-foot shelf that was only 11 inches. The other thing is if we actually use our number structure, 8 feet is really 2 yards and 2 feet. 2 times 3 is 6 plus 2 is 8. For some reason, feet we allow to get very large. So if we have a room that's 12 feet by 16 feet, or let's make it 15 feet, that room is really 3 by 5 yards, or 4 by 5. It should be a little bit better in my arithmetic. One of the things I found interesting, I wanted to have my floor tiled, and the 2 things I found is that if I put the tiles at an angle, it would end up costing me more, even though it's covering the same area. And I also figured out that the extra cutting is insignificant. But I also found a surprise that when I paid for my tiles, I got from one of the local stores, the labor was included in it. And one of the suggestions is to save a box in case they break. Well, it turns out the best thing to do was to take the box back to the store, get my money back, and then rebuy the box without the labor rate in it. Okay, and then the last section is time. Well, what base system are we working with in time? It's 60 seconds in a minute, 60 minutes in an hour, but there are 24 hours in a day. And then there are 7 days in a week. Time is really messed up. It would be more convenient if a year was 13 months with 28 days each, plus leap days to make up for the extra day or 2 that's missing. If we did it this way and didn't give days of the week to leap day, if we knew that the first of the month came on a Sunday, the first of every month would come on a Sunday. Okay, so let's summarize what we've learned in just a couple statements. What is number structure? The purpose is to make very large and very small numbers understandable within the psychological and physiological limits of the brain. Able to make very good cost savings after understanding sales tax and exponential growth is the benefit that we get from understanding number structure. And other films as part of this series, I will be going in and trying to make number structure very easy to understand and give the wide areas that we recover. Thank you again for watching.